For the last section of our review for the quiz, we are going to talk about the problems that are in the 1.2 section. So a couple of things you should see. You should know the difference between acute, right, obtuse, and straight angles. You also should be able to convert degrees to degrees, minutes, and seconds, and the opposite way. We should be able to do arithmetic, so adding and subtracting degrees, minutes, and seconds, and you should be able to do a clock problem. Now, as a caveat here for the clock problem, and this will be posted on Schoology as well, I am going to put a clock problem on the quiz to see what you can do, but I intentionally am not going to count that into the quiz score. So it won't be, I will score it for you so that you can see how you did. I'll check it, but it won't count for any points. It will be a 0-point problem because we didn't spend as much time on the clock problems. So let's look through these examples here. For the first one here, number 3, it says convert 42 degrees, 18 minutes and 20 seconds to degrees. As a reminder, we have in every 1 degree, there are 60 minutes. And then for every 1 minute, that is equal to 60 seconds. And then we determined that in 1 degree, there were 3,600 seconds. So those are all our useful conversions here. So we have to convert, we need to figure out for the seconds and the minutes, what fraction of a degree that is. So we want to divide them by how many seconds or how many minutes there are per every 1 degree. So for my 18 minutes, I'm going to divide that by 60 total minutes per degrees. That gives me an exact decimal of 0.3. And then for 20 seconds, there are 3,600 seconds in 1 degree. So we do 20 divided by 3,600. I'm going to round this to 4 decimal places. You could do 3. Just make sure you keep enough to have an idea of this. And then add it all together that this is about 42.3056 degrees. And that is how we convert this. Looking at number 4, we have 77 5/9 of a degree. And we want to convert this to degrees, minutes, and seconds. So I need to figure out how many minutes is 5/9 of a degree. So if I have 5/9 degrees and there's 60 minutes per every 1 degree, if I multiply this by 60, that gets me to my number of minutes, which comes out to be 33 1/3 minutes. Now, if we didn't have any other units, we would just stop. We would say it was 33 1/3. But minutes can also be broken down into seconds. So I want to take this 1/3, this partial minute, and convert it into seconds. So I have 1/3 minute. Now there are 60 seconds in a minute. So we're going to multiply that also by 60 seconds. And that gives us that 1/3 of a minute is the same as 20 seconds. And hopefully if you think about a clock, that makes sense to you. So now we're going to put this all together to make it 77 degrees, 33 minutes, and 20 seconds. So if you finish, when you multiply by 60, if you have a decimal or a fraction left over, you need to take that decimal and then multiply it again to turn it into seconds. If you don't, if we just gotten a whole number of 33, then we would be finished. We don't have to convert because we don't have any partial minutes to convert into seconds. All right, number 5. For number 5, we have these 2 quantities in degrees, minutes, and seconds. Now, on the quiz, I'm going to ask you to have the answer in degrees, minutes, and seconds. So I want you to start to get comfortable adding them together this way. So we set them up as an addition problem. Line up your degrees, line up your minutes, line up your seconds. With addition, we can first start and just add down our columns. So we get 30 plus 18 is 48, 24 plus 52 is 76, and then 60 plus 50 is 110. Now, we have an issue. 76 minutes is more than 1 degree. That is more than the 60 minutes that are in a degree. So we need to take this and regroup it into 1 degree and 16 minutes. Then that 1 degree adds in to make this 111 degrees and 17 minutes. So if any of your measurements for minutes or seconds are over 60, you need to regroup them because we don't want to mix our units here. We always want it to be under the threshold for 1 whole degree or 1 whole second or 1 whole minute, because otherwise we need to regroup them. All right, number 6. For number 6, what you can see here behind my regrouping is that I took the 60 degrees, 24 minutes, and 30 seconds. I lined up underneath to subtract the 50 degrees, 52 minutes, and 18 seconds. So I would first start working your way from this time. We usually work left to right in a problem. This time we work right to left. Start with the seconds, our smallest units. Those do subtract. That gives us 12. Great. I get over to my minutes and I have a problem. 24 is smaller than 52. I can't subtract 52 from 24 and get a positive answer. So this is where we need to borrow. When I have 60 degrees, I can borrow one of those degrees and I can convert them into seconds. So what I do is I take 1 degree and that gives me 60 seconds. I'm going to add that onto the 24 I already have to give us 84 minutes to work with. And now we can subtract 52. That gives us 32 minutes. And then now we go back to our 59 degrees left over, subtract 50 from them, and that leaves us with 9. So that gives us a final answer of 9 degrees, 32 minutes, and 12 seconds. For these, you should never have to regroup. It's only addition. Once you finish, you'll never have to regroup. You might have to regroup to do the problem. With addition, you might have to check your final answer to make sure every minute and second is less than 60. All right, a couple more. Number 7. Number 7 asks us, according to this diagram, which 2 segments are congruent. So we want to look for tick marks on our segments. And so I see a tick mark on BC and on RT. So that means those are congruent segments. So that means BC, with the segment line on top of it, is congruent. So equal sign and a tilde to RT. And then for B, it says angle, which 2 angles are congruent. Now they give us a bunch of different symbols here. This is a matching game. They are only congruent if they have the exact same symbols. So either they both have 2 arcs or they both have an arc with a line. So I'm going to look for any of these. So the double arcs here at angle C, I don't see any other double arcs. So we can't use that pair. This arc with a circle on it, I don't see another one of those. So that doesn't have a pair. But looking at A, I have an arc with a bar through it. And an S, I also have an arc with a bar. So that means those 2 have the same measure. They are congruent. So that means angle BAC is congruent, equal sign with the squiggle, congruent to angle RST. In this case, you could call them angle A and angle S. That would be okay here too, because there's only one angle at each vertex. Okay, for number 8, we have angle A congruent to angle B. This means for us here that they have, if 2 angles are congruent, they have the same measure. So since they have the same measure, I can take these expressions, the 2x plus 5 and the 50 minus 4x for those 2 angles, and I can set them equal to each other. So that gives us 2x plus 5 equals 50 minus 4x. When I solve this all the way through, it gives us 15 halves or 7.5. Fraction or decimal is fine. I prefer fractions, but some people are more comfortable with decimals, so I'll give both. The great thing about this fraction is that now I need to find the measure of angle A. I need to finish the problem. So we're going to go back to our expression, 2x plus 5 degrees, and substitute 15 halves in for x. So this gives us 2 times 15 halves plus 5 degrees. So the 2's cancel, leaving us with just 15 plus 5, so that makes the measure of angle A 20 degrees. Lastly, a clock problem. So first thing that hopefully we have done is sketch out a clock and draw in the time 5:40. So we start here, draw the minute hand to the 40 and the hour hand to somewhere between the 5 and the 6. So next thing I encourage you to do is to sketch your dotted lines all the way through to connect to any of the hour hands, any of the tick marks between your hour and your minute hand. So I have 2 lines here, breaks it up into 3 sections. Then the next thing we want to do is determine how many whole sections we have. I have 1 full section here, 1 full section here, and a partial. So the two full sections are each 30 degrees, so I know I'm starting with 60 degrees. Now next up, remember we've said this hour hand, every time it ticks half of a degree. So we want to figure out with how many minutes have gone by in the hour, how much has it moved, and that helps us know what to multiply 1/2 by. Now in this case, it has moved 40 minutes past the 5 to get to where it is now. But that's not the portion that we're trying to find. We're trying to find the angle that is just past the hour hand heading toward the 6. So this is where we have to engage our critical thinking a little bit. If it's not 40, I want to ask how many more minutes does it need to go to make it to the 6? That's going to be 20 more minutes until 6 o'clock. So rather than using 40, we are going to use the 20 minutes left. So 20 times 1/2 means that angle right there, it is 10 degrees. Adding the two together, that gives us that in total, this is a 70 degree angle. This is a 70 degree angle. All right, that is it for this section and for our review for the quiz. Hopefully this helps you feel better prepared. Please email me with questions that you might have, and then we will also go over quick questions for our first couple minutes on Monday.